And I'd like to invite our next speaker, Mr. Shinichi Ishikawa from Adeka. Ishikawa-san would speak to us about stabilization of polyolefins for the automotive applications. So leave the stage to him for his presentation. Okay, here you go.
Good morning, ladies and gentlemen. Firstly, I'd like to say my appreciation to the organizer to invite me to this conference here. And I'm very happy to make a presentation at Adeka's 100-year anniversary year. So today, I'd like to talk about a superior weathering solution for the PO basis automotive parts using advanced hindered-arm light stabilizers. This is the agenda of my presentation. Firstly, introduction. I will explain the PP degradation and stabilization and the function of the house as light stabilizers briefly. After that, I'd like to introduce the advanced house technology in the automotive parts, light stabilization for the hard parts application, and soft suited house system for the soft some plastic elastomer application. And finally, I will be in the summary and the conclusions. So, as you know well, unstabilized polymer degrades easily under various conditions, such as thermal conditions, mechanical stress, and ultraviolet exposure. And auto-oxidation reaction accelerate the degradation of the polymer. As a result, degradation of the polymer occurs, appearance changed, and discoloration occurs, and changing of the mechanical properties. So, such as addition of antioxidants such as phenolic and phosphate type antioxidants, and light stabilizers like a house indispensable for long-term utilization. This is a polymer degradation and stabilization system. Probably everybody knows the polymer we showed. Sorry that. Okay, RH is a polymer. Then by the UV and heat, stress, metal. Then proton is extracted. Then the R radical is generated. This R radical can react with oxygen very first. Then peroxide radical is generated. Then the peroxide radical extracted the proton from the polymer. Then hydroperoxide generated. This is auto-oxidation system, auto-oxidation reaction. Then additives is necessary to protect this auto-oxidation reaction. And then today, I'd like to focusing on the house, like this. So this is stabilization mechanism of the house in the polymer, as you know. So probably you know the house has found in the 1970s centuries, in 1970s. So it's been the, almost 50 years history. This, however, this is the mechanism has not been completely confirmed yet. Well, it is very interesting. So this is a mature type house can become the NH type house. Then NH type house become the NO radical type. product. This radical type product is a very important form of the house to protect the oxidation of the polymers. So our house trap unintentionally generated free radicals or unstable intermediates, and which result in inhibition of oxidation. So this is identifying suitable household applications. As I mentioned, there are several types of the house, like NH type, N-mature type, NO-alkyl type. So there are differences on the reactivity against the radicals and absorption to the fillers and the basicity. It means the formation of salt with acidic substances, which lead to deactivation of the house. In order to have sustainability, so house must stay inside the resin, but migration is also migration to the surface is also very important. So we need to consider the molecular weight of the house and the compatibility of the house. So suited house depend on the application. Let's move to the advanced house technology in automotive parts. As you know well, the polyolefin has good superiority, such as low density and superior mechanical properties, and excellent chemical resistance, and recyclability, and easy of processing and molding, and cost effectiveness. That's the reason why the polyolefins has been used for the many parts of the automotive. So such as instrumental panel, bumper, as hard materials. And in case of the soft material, elastomers, the elastomer can be used for the instrumental panel skin and the glass line channel and so on. So I would like to talk about the suitable house for these parts and applications. This is a requirement on the house for the automotive parts. For exterior parts, such as the bumper, is exposed to the direct sunlight, which leads to the necessity of light high weatherability and thermal stability. In addition, the low compatibility of the house can affect the paintability issue. On the other hand, interior parts application, of course, the against the sunlight is very important, and the interior parts required weatherability and high thermal stability, because the temperature inside the car could become much higher than the outside. Also, high compatibility with the resin is required to avoid the fogging and the blooming issue. So requirements house is high performance and high compatibility. Our solution is, the first solution is LA1, Adeka Stab LA402AF. This is an H-type house plus synergy system. This product has good benefits, excellent weatherability, stability ability, and a superior compatibility with the polymer. So this product can use for the both exterior and interior parts application. This is additive used in our evaluation. House is LA1, LA402AF. And reference one is our LA77Y, and the reference two is our LA94G. Let's see the weatherability of the interior parts, color stability, in terms of the color stability. Y-axis is delta E, and then x-axis is exposure time. Compared to the combination of the reference 1 and the reference 2, total 0.2 pHR. 0.2 LA40% of the LA42AF can provide the same or better performance. And if you can add the little more, 0.3%, you can have much better weatherability of the parts. And this is weatherability of exterior parts in terms of the surface gross. So y-axis is a gross retained percent, and x-axis is exposure time. So compared to reference 1, combination of the reference 1 and the reference 2, totally the 0.2%. 0.1% LA1 can provide the same performance as a combination of the reference 1, reference 2. And if you can add a little more, 0.2%, so the gross retention is much longer than the reference 1, reference 2. LA1 improved the surface gross stability greatly compared to the conventional type house system. And let's see the blooming behavior of the house from the polypropylene. So y-axis is the gross retained after 500 hours and 1,000 hours oven aging at 8 degrees C. Compared to the reference 1, the LA1 demonstrated lower blooming on the surface of polypropylene compared with other low molecular house. So it means by using the LA1, you will not have any blooming issue. So next solution is a mature type house system, especially for the interior parts application. This is LA2. Adeka style LA502XP. This is an mature house plus synergy system. The benefit of this product is superior thermal and light stabilizing activity, color sustainability, and long-term heat resistance. And this product also has superior compatibility with the polymers. Especially, this product is very suitable for the interior application. This is additive used in the evaluation. LA1 is, again, LA502XP. The chemical structure is here. And then reference 1 is LA77, and then reference 2 is LA94. Let's see the thermal stability of the polymer by the oven aging at 150 degrees C. Y-axis is time to crack formation. And then please look at this graph. In terms of the thermal stability, LA2 can provide higher thermal stability compared with conventional house system. This is the effect of the mature house. We confirm the effect by using the model experiment. So y-axis is the consumption of oxygen, and the x-axis is time. So the performance of the house to protect the auto-oxidation, we conducted this model experiment by using the normal hexadecan. So in case of the NH-type house, consumption of the oxygen is very fast, and it depends on the chemical structure. So if you change the type of a house from the NH type to N-mature type, then thermal stability of consumption of oxygen is much lower than NH type. So it means in a mature house have higher activity to trap free radicals or unstable intermediates, resulting in inhibition of the chain propagation reaction in oxidation. So in terms of the thermal stability, in a mature house is very good. This is a summary of the hard application. Advanced NH house system Area 1 provided remarkable weathering resistance compared with conventional type at the low loading level in the both exterior and interior formulation application. And then advanced N-mature house system Area 2 provides high thermal stability, which is especially required for interior parts application. And next, let's move to the soft TPE. And as you know well, the generation, this is a formulation of TPB. Polypropylene, polyethylene, EPDM, oil fillers. So due to the difference in the compound formulation, performance of the house may differ from hard PP application. And requirement I summarize in this table. NOx gas resistance is important, and the weathability also. And for the interior parts, the blooming, thermal stability, fogging resistance also required. Then our solution is Area 3, a mature type house plus synergist. So benefit of the Area 3 is a superior performance against NOx gas discoloration and good compatibility to the polymers. Another solution is Area 4. This is based on the Adeka style Area 81. This is the chemical structure of the Area 81, NO alkyl house plus synergist. This product is very unique. Even though the low molecular weight, this product has very, very good compatibility to the polymers, polyolefins. So both systems are very suitable for the TPE application. This is the additive used in the evaluation, Area 3, Area 4, and the reference 3-4 is our competitors NO alkyl type house. Let's see the weathability of the weathability performance in terms of the surface deterioration. So we check the weathability by checking the time to carbonyl index. So as you know, during the degradation, the carbonyl index is increased. So we utilized this number to check the weathability. Compared to as you can see on this graph, compared to the reference 3-4, so our Area 3-4 system can provide excellent weathability or comparable weathability. And in terms of the delta E, at 2,000 hours, during open aging at 120 degrees C. So delta E number of our Area 3, Area 4, lower than the reference 3, reference 4. It means in terms of the thermal stability, our product, Area 3, Area 4, superior to the reference 3, reference 4. This is anti-NOx discoloration behavior. With AO1 is our AO60, equivalent to the 1010 type. And then AO3 is our AO20, equivalent to the 1314 type. So, the condition of the NOx gas exposure, 700 ppm NOx gas at room temperature for 24 hours. So compared to the reference 3, reference 4, the area 3, area 4, NOx gas discoloration is much lower than reference 3, reference 4. So in terms of the anti-NOx discoloration, area 3, area 4 are also very suitable to protect the discoloration. And this is a fogging resistance behavior. So the fogging evaluation was conducted at 100 degrees C for 24 hours. So we measured the haze after 24 hours on the surface of, on the top of the glass. So compared to the reference 3, reference 4, area 3, area 4 number is much lower than lower. So it means both area 3 and area 4 showed better compatibility and fogging resistance than reference 4, reference 3, reference 4. This is the compatibility of the house with the polymer. So this is also the model experiment. We checked the solubility in the heptane. As you can see, in the LA3, the main house of the LA3, LA4 has a very, very good solubility in the heptane. And then reference 3 is a little poor, but reference 4 is also very good, the compatibility. So it means LA3, LA4 is expected to have excellent compatibility with polyolefins. This is the basicity of the house compared to the reference 1, NH type, reference 2. So as I said, the fourth main house is NO alkyl, LA81. It has a low basicity. So it means there is almost no salt formation with carboxylic acid. So LA4 is possible to function with existing of acid substances. So this is performance of the LA4 with thioester type of the antioxidant. So y-axis is the time to crack formation, and this is xenon type. We used the xenon type weathering machine, 89 degrees C, the black panel temperature, and without spray. As you can see, in case of the without the thioester type, the antioxidant, the house, even the difference one house can provide excellent weatherability. However, with along with the thioester type antioxidant, the weatherability is drastically decreased. On the other hand, in case of the LA4, you can keep the good weatherability. So this formulation can provide the good weatherability and thermal stability at a higher temperature, such as 150 degrees C. This is a summary of soft application. Novel house system, LA3, LA4 had good compatibility in polyolefin and showed high performance in formulation of soft application as well. And LA4 NORQ type house showed excellent light stabilizing activity in compound containing acidic substances. This is a summary and the conclusion of my presentation. There are multiple factors that determine the performance of the house, as I mentioned. And by selecting the suited house for the several applications, it will provide the compound with the performance necessary for automotive parts. So it means by combining these houses with other additives, it should enlarge the possibility of the polyolefin for automotive parts. My message is the suited house is have to be selected to maximize the performance of the plastics in the automotive parts. Thank you for your attention. If you have any requests, please contact our local, company, our affiliates in India. Thank you very much.